So we left off, we did the first example together, right? We did the first example. We did one test all the way through. Tomorrow, if we don't finish the notes today, we'll finish it tomorrow, and then I'll let you work on the assignment in class tomorrow. That's what we're going to do. So if we don't finish the notes today, we'll finish them tomorrow, and then tomorrow I'll let you work on the assignment. If we finish them today, I'll just let you work on the assignment for tomorrow. That's all we're doing for this week, because that's really half the chapter. And the other half is the exact same thing, but guess what, with means instead of proportions. That's all this chapter is. It's very short in terms of new stuff, okay? But I want to go over some more because we only did one test together, okay? All right, so hypothesis tests. Hypothesis tests. We went over what a hypothesis test is, right? It's a procedure. It's an inference procedure for using observed data, for using a sample, to decide between two competing claims. Those two competing claims are called the null hypothesis and the alternative hypothesis, okay? Okay, so we talked about hypotheses, how to write those, right? The claim is what's stated or what's believed versus what we suspect is true or what we're trying to show, okay? There are 7 parts to the hypothesis tests. The 2 highlighted ones are the new ones, or the new parts, right? On the board here, I put some of the new things on here. Like population parameter number 1 is the same. It's the same since we've been doing since chapter 7. Nothing's new. 7 and 8. Conditions, assumptions, those are the same, right? So the 4 of them that I put are the new ones. Okay, those are the ones I put on the board. They're in your notes too, but I just put them on the board just so that they're handy. All right. Okay, so let's look at example number 2. Example number 2. Okay, so according to the Association of American Medical Colleges, only 46% of medical school applicants were admitted to a medical school in the fall of 2006. Okay, so only 46% of the people who applied to a medical school got in. Okay. 2 years later, a random sample of 180 medical school applicants was taken. Out of those 180, 77 were admitted to a medical school. Okay. So what we have to do is 2 things. First thing, does this data provide evidence of a change in the acceptance rate for medical schools? And then it says carefully interpret the meaning of the p-value that was calculated in part A. Okay, so first thing, let's look at what we have so far. Let's see. First of all, is this proportions or means? Proportions, yeah. It's proportions. It's not that hard. This notes is titled proportions. It's proportions in the title. But, on a test, they're not going to tell you that. So it's good to know. So it's proportions, right? So what do we know? What was the sample size here? 180. Okay. Since it's a sample of 180, we're going to have a p-hat, a sample proportion, right? What was the sample proportion in this case? 77 over 180, right? So we're going to change that to a decimal. .428. Okay. All right. So that's the stuff we're pulling out. So if you look at A, question A, does it say anything about a test, doing a test? Does a test, significance test, hypothesis test, anywhere in question A? Anywhere in this question right here, does it say anything about a test? It doesn't, right? In chapter 8, it always said, on your test, it always says, you do a confidence interval, construct a confidence interval. That's where tests are a little bit tricky. But there's some buzzwords, there's some phrases, right? We talked about this on the last question. Does this provide evidence?
They say that that's when we do a hypothesis.
That means it's a test, hypothesis test. Yep. Just like in number one. Number one, I believe does this provide evidence, right? Providing evidence is always a test. Means it's keyword, it's buzzwords for do a test. Okay? So let's do a test then. So for part A, we're going to do a test. Let me separate this. We got A. Population parameter, P equals. Since it's proportions, it's always going to be P, not P hat. We know P hat. P is what we're trying to find. So that means we're going to start true proportion.
Do we still label population parameters?
Mm-hmm. It's good to label. I didn't label mine, but it's always good to label so that whoever your reader is, population parameter. So it's easy to spot. The more well organized you are, the easier it is to grade, which means you're probably going to get a better grade. Okay, so true to proportion. So we have p hat. P hat is this number, and that refers to the sample proportion, right? P is going to refer to the true proportion of who, though? The sample proportion is the 180 that were randomly sampled medical students that were admitted, right? Medical school applicants that were admitted in the sample. Then who is P? The true proportion of? Here you go. Medical school applicants who were admitted to med school. Okay. That's 1 point. Next one. Next one is hypothesis. Okay, this is one of the new guys. Hypotheses, because we have 2 of them. We have the null hypothesis. Oops.
Can we also write it out, or do we have to use the symbols?
You can write it out. Mm-hmm. You can write it out. Just make sure, just make sure when it's written out fully. So if you don't use the symbols, make sure you write it out fully. Don't just, We use the symbols just because it's quicker and it's easier, but you can write it out. P equals. So let's go back to the question. What is the claim? What are we testing? We're testing to see if there's a change in the acceptance rate. So that was the previous, right? We're trying to test whether it's changed. That guy is changed, right? So the claim is 46%. The alternative hypothesis is always going to be the same, except it's going to be either greater than, less than, or not equal to, right? It's either going to be one of these 3 guys, okay? So looking at the question, which symbol are we going to go towards? So go and look at the question, A. Not equal to. Because of which word? There's one word. Yeah, it's just a change, right? What kind of change? They don't say. They just say change. Any type of change. Could be higher, could be lower. They don't specify like they did in the previous question where it says a lower effectiveness, right? So that's when we use the not equal to. Okay? significance level. They don't specifically give us a significance level, so we're just going to use the default, which is 5%. Okay. Test statistic, it's on the board. It's also in the notes. The test statistic or formula. It's just test statistic is just another term for formula. You can just write formula if you want. Z equals P hat minus P. And then the bottom is the standard deviation. Oops. 1 minus P over N. Okay. All right. So that's 4 of the things we need to do. The next one is assumptions conditions. All right. So I'm going to find some room over here. Conditions. And then check that. Okay. Same ones as we've always done for proportions. SRS or random sample. 10% condition.
For the third one, which is finding the shapes normal, do we use the same one as the proportions?
Proportions is always going to have the same. If it's proportions, they're always going to have the same 3. Okay, yeah. All right. So the 180 random sample stated. 10% condition, N is less than or equal to 10% of big N times big N. So N in this case is 180. We don't have a number for big N, but we can put it in words. If little n is the sample of 180 medical school applicants, what would big N be? There you go. All med school applicants. Okay. And then the last one, we use N times P is greater than or equal to 10, along with N 1 minus P greater than or equal to 10. Yeah, go ahead. So N is 180 times P. We don't have, oh yeah, we do. We have P, 0.46. 0.54. So 82.6 and 97.2. Okay, they both check out. Okay. All right, so that's the next one. Next one is calculations. Last two, calculations, where we calculate the p-value. Well, it's a z-score formula, so we're gonna need to use the normal distribution. Okay. So what value is going to go in the middle? 0.46. Yep, the claim. Claim always goes there. Now, the sample was a little bit bigger, smaller, 0.428. So that's going to be here. So here is where this type of test, this is called a two-sided test. It's called a two-sided test because we chose not equal to, right? Not equal to means two things. It means it could be smaller or it could be bigger, right? There's two options, right? Greater than or less than, only one option. Greater than means it has to be greater than. Less than means it has to be less than. But not equal to gives us two options. That's why it's called a two-tailed test. Okay? So, first thing is, it could be less, right? So we're going to shade less than this guy right here. That's one option, right? The other option is it could be greater. So where do I shade to the right? Here's the thing. A lot of students think, oh, when you shade to the right, just shade this. If I shade that, what part would be shaded? What percent would be shaded of the curve if I shaded this part and the green? All of it, right? So that's kind of defeating the purpose, right? So which part do we shade? Well, what I'm going to do is, how far away from the center was I here? So let's crunch those numbers. How far was I away here? 0.034, right? What I'm going to do is I'm going to match that distance. So if this was 0.034, what value would be here? What value would be here? Same distance away. .494. That's where we shade our greater than. That's where our greater than is going to be shaded. It's the same, since a normal curve is symmetrical, these are going to have the same proportions. The greens are going to be the same size. So all I have to do is find one of them and double it. Now, when do we do this? The only time you do this is when your hypothesis, your alternative, is not equal to. We didn't do it for example number 1 on Tuesday because that wasn't our hypothesis. Our hypothesis for the first question was less than. So we only shaded less than, right? If it said greater than, we would only shade to the right. But since we have a not equal to, we have to take into account both sides, the less than and the greater than. So we have two sections that are shaded. Okay. But the lucky thing is they're both the same size. Because the curve is symmetrical, and they have the same distance away from the center, both green are exactly the same size. So find one of them and double it. So really it's not doubling your work, it's just whatever answer you get, double it. Okay? So let's use our formula. So our formula was p hat 0.428 minus the claim, which is 0.46, over p 1 minus p over n square root. And I get a z-score of negative 0.86. That's the z-score for this guy. What do you think the z-score would be for the other guy, 0.494? Positive 0.86. Because it's symmetrical, and they're the same distance away from the center. And then the center has a z-score of 0, always. Okay. So we go to our tables now, z-score tables. And we look at negative 0.86. Negative 0.86. Right here. 0.1949. 0.1949. That's only going to be one side. The other side is exactly the same. So our p-value is all of the green. So our p-value is actually double. Add those two up. This is our p-value. Our p-value is all of the green, not just one of the greens, both of the greens.
So we just add these two?
Yep, they're the same size. So you just add them up, and you get the green. Okay, so that's calculations. Conclusion. I put the sentence frame on the board. It's also in your notes. Our conclusion. 3 things we have to show. Since the p-value our p-value in this case was 3.898, is less than or greater than. Well, in this case, the p-value is bigger than alpha level. Since we said greater than, since the p-value is bigger than the alpha, it's always going to be fail to reject. Fail to reject. The null hypothesis. The null hypothesis was that 46%. It was 46%, right? So what we're saying is, I don't know if that's wrong or not. I don't have enough information to say that that number is off. Has it differed? I don't know. I don't have enough information to say it's differed. That's what the second bullet point says. Okay? So since we fail to reject, we say therefore we lack sufficient, significant, enough, any of those terms. Evidence to show or to suggest that, and then this is where we put the alternative in words, where we got to put the alternative in words. We have it in symbols, we have to put it in words. So the alternative was the true proportion of med school applicants that get into med school differs from 0.46. That's what this says in words. P is the true proportion of med school applicants who are admitted to med school. Oops. Differs from 0.46. That's what we're going to put. Okay. That. Done. Okay. The guys in blue always go together. If I would have said less than, then it would have been reject. Then it would have said we have. Reject. When we reject a claim, we say they're liars. Your claim is wrong. We have significant evidence. We do have enough evidence to say you're wrong. Fail to reject means, are you right? I don't know. We just don't have enough evidence to say you're wrong. That's the difference. That's the difference between them. Okay. Part B. But there was a part B, right? Part A was that. Part A was the test. So does this data provide? No, we don't have. Like I said, that's our conclusion. We don't have sufficient evidence to suggest that there's a change, that it differs. Right? We don't have. So B, carefully interpret the meaning of the p-value that was calculated in part A. Okay, so the p-value was right here, right? How do we interpret that guy? There's a sentence frame. I have a sentence frame for you. Right here. You only have to do this when you're asked to. You won't be asked to a lot. Rarely are you asked of this on a test, but they might ask you on an assignment. Okay? Most of the time, they don't ask you to identify or to interpret the p-value. Okay? So if the null is true, the probability that a statistic at least as extreme as the observed value would occur is, okay, so this is what our sentence frame is going to be. I'll underline the words. If the null hypothesis is true, the probability that the statistic a statistic at least as extreme occur is blank. Okay. That's going to be our sentence frame. If the null hypothesis, what was the null hypothesis? That was the claim, right? 46. If it's true that 46% of all med school students, applicants get into med school, the probability of the statistic at least as extreme as the observed value would occur is 0.3898. What it's saying, in as basic English as possible, is it's saying, okay, so if what you're saying is true, which is the true proportion is 46%. If what you're telling me is true, the chances that I got a sample like I did is around 39%, 0.3898, right? So if what you're saying is true, that the population proportion, that the true proportion of all medical students who get into school, medical school, is 46%. If that is actually true, then the chances that I would go out and actually get a good sample of 180 students, and out of those 180 students, about 42%, 43%, 0.428, the chances I would get a sample proportion like that is the p-value. Okay? So if the p-value is really small, that means what you're telling me can't be true. The claim can't be true. Right? How small does it have to be? It has to be below significance level. So if it's below the significance level, it's too low. There's no way, if what you're saying is true, right? If I tell you there's a 99% chance it's going to rain today, and it doesn't rain, yeah, I was a liar, right? I was wrong, right? But if I tell you there's a 1% chance it's going to rain today, and it doesn't rain, right? You couldn't call me a liar because it didn't rain, right? It's kind of like that, where if you state a claim, and that claim, if that claim is true, the p-value will tell me if you're a liar or not. Okay, so that's why the p-value is always compared to the alpha level. You got to be careful though, because if I'm a company, and like anytime a company says something about their product, this pen, new and improved pen, new and improved, it does this, it does that, it does this, right? They can't just say that, right? It's false advertising if they say that. They have to have a way to back it up. Like if they say, like every time Apple puts out a new iPhone or a new iPad or a new computer, they always say it's 40 times faster. It's twice as fast. Its battery lasts twice as long, right? They can't just say these things. They have to actually have evidence to back it up. So what do? They take a sample, right? They take a sample of the new battery time lengths, however long, right? Find the average, and they run a hypothesis test, right? They run a hypothesis test. And what they want to do is they want to get a p-value so small that they can reject their old claim, which was our battery lasts this long, right? They can reject. That's what they do. But you got to be careful, because how do we know if we reject or fail to reject? What's the thing that tells us whether we reject or fail to reject? When do we know if we reject or fail to reject? Less than what? Mm-hmm. This guy, right? This is the bar that we need to go under. right? To reject. If this is the bar, shouldn't I state it before I do anything, before I do any tests, before I do any calculations, right? I need to set the bar, right? Think of this is a bad example because it's over, but think of an athlete and you do track and field, and there's a bar you have to go over, jump over, whether it's high jump or whether it's pole vault, right? You got to know where the bar is before you jump, right? Because otherwise, there's no point, right? It's the same thing. You have to set the bar before, right? When people go into court, if you're charged with a crime, the bar is already set. Does anyone know what bar that is? What the bar is for court for guilty or not guilty? There you go. Reasonable doubt. That's the bar that's been set. So if you're a juror and you figure beyond a reasonable doubt they did it, that's the bar. I crossed it. You're good. You can vote guilty. But if you haven't crossed that bar, you have to say not guilty, right? That's your job as a juror. When you turn 18, you go to jury duty. That's your job. If you get picked for a jury, that's your job. You have to listen to all the evidence and say, has it crossed that bar of reasonable doubt, right? Reasonable doubt means more than, they might have done it, right? They probably did it. They probably committed that crime. That's not reasonable doubt. Reasonable doubt is you have to beyond what they say is beyond reasonable doubt, right? You have to be pretty sure that they did the crime, right? And not only do you have to be pretty sure, you have to show that the evidence shows that. You can't just give an opinion, right? It's based on the evidence. It's the same thing as when Apple says, my computer or my iPad or my phone is the battery lasts twice as long, right? They have to set the bar before they can test the stuff, right? Because let's say you have a p-value of, let's say we have a p-value. Let's see. Let me get another page here. Let's say we do a problem and we have a p-value of this. That's our p-value. If I have an alpha level, if I've already stated an alpha level of 0.05, am I going to reject or fail to reject? Is it green or blue? Or no, sorry, red or blue? P-value, alpha level. P-value is too big, right? P-value is bigger, right? Blue. So we fail to reject. We don't have enough evidence. In that case, Apple can't say that their phone is twice as faster. Don't have enough evidence to. But what Apple can do is this. Oh, well, I didn't mean that was the number. I actually meant this is the number. Now you can reject the previous claim, right? You can reject the previous claim and, oh, now the p-value is less, so I can reject the old battery time. Now the battery times, I have evidence to show that the battery time is better, right? So you have to be careful with that because you can change the level you have to meet, right? That's kind of it's manipulating the statistics. That's why a lot of people hate statistics. A lot of people, like if you talk about numbers or statistics, they're like they don't like statistics because people can do this to them sometimes, right? But what we have to do as statisticians is come up with this number first. That's why we do it early before we calculate the p-value, right? So that's why we have to come up with our alpha level. Because, like I said, the difference between rejecting and fail to reject is very close. Okay? So you just got to be careful with that. And it's just like anytime you watch TV, you watch YouTube videos, and there's always commercials in between. They'll always say new and improved, better than the last one. They're trying to sell you on things. Well, they can get in serious trouble and be fined millions of dollars if what they're saying is wrong, right? Real quick, last thing we'll do. In Australia, someone sued Subway restaurants, Subway sandwich restaurants, because they said they went in and bought a 12-inch sandwich, right? Foot-long sandwich. Well, the claim is, if it's a 12-inch Subway sandwich, how long should the sandwich be? 12 inches, right? That's what you're claiming. What they did was they did a sample. So what these people did in Australia is they took a sample of Subway sandwiches and they measured each one of them and found the average. And the average was actually lower than 12. And then they ran a hypothesis test. And they got a p-value that was low enough to reject. And they're like, we have enough evidence to show that your sandwiches aren't actually 12 inches, foot long. They went to a court, they sued them, they went to court, and they actually won. It was less than $1 million, but it was still several $100,000 they won because Subway was proven to be lying about their claim. It's called false advertising. You can't just say things without proving them, right? So so that's a real life. It was a few years ago. It was pre-COVID, but that can happen. Okay, that can happen. But so that's why it's important to set your significance level early, right? So that you can. Rejecting means you're wrong. Subway is wrong. I have enough information. I have enough evidence to show they're wrong, right? Fail to reject means I don't have enough evidence. Are they wrong? I think so. I'm not sure, but I just don't have enough evidence to say that. We never say they're right. Yeah, great point. Yep, we never, ever, ever. Where is it? Accept. We never say you're right. Accepting means you're right. Okay, I accept it. That means you're right. We never say that the null hypothesis, that their claim is correct. We either say we reject or we fail to reject. All right? All right. Okay, we'll do the last one tomorrow. And then I'll give you the rest of the time to start on the assignment. Okay?